So you have learned all about if statements. Now in C++, we have another statement for making decisions, and that is a switch statement. Let's see it in action. So let's start off by printing a menu for the user. So if they press 1, let's say they want to create an account. Now on the second line, we're going to give them another option. If they select 2, they're going to change the password. And if they press 3, let's say they want to quit. Okay. Now on the next line, we're going to ask them to select a menu. So select an option. Next, we need to read the user's selected menu. And for that, we need a variable. So short, you could call that input. And then we use cin to read the input. Now here we can use an if statement to execute different actions depending on the user's selected menu. For example, we can say if input equals 1. Now here we could have the logic for creating an account, but let's not worry about this complexity and just focus on making decisions. So to simplify this, we just want to print a message and say you selected 1. Okay. Now else if input equals 2, we're going to do something similar. So we're going to print you selected 2. And finally, for anything else, we're going to say goodbye. Okay. This is totally fine, but we have another statement for implementing this kind of logic, and that is a switch statement. So let's see how we can rewrite the same logic using a switch statement. And then we'll compare them side by side so you can see the differences. We start with the switch keyword. Then in parentheses, we type our variable, which is input. Then we add braces. Now inside the braces, we add one or more case labels for each value. So here we're comparing input with 1 and 2. So we need 2 case labels. So case 1, we add a colon. Now here we type the logic that should be executed if input equals 1. That is this statement over here. So let's copy and paste it right here. Then we need to terminate this block using a break statement. Okay. Now we add the second case. So case 2. So if input equals 2, then we're going to do something else, which is printing this message. So let's print that. And one more time, we use the break statement to terminate this block. If we don't use a break statement here, what's going to happen is if input equals 1, this statement is going to get executed, and then the control will move to the next statement. So this line will also get executed even though input does not equal 2. So here we need to add a break statement to prevent the subsequent statements from getting executed. Okay. So this is a switch statement. Now in a switch statement, we can optionally have a default label, and the code in this block gets executed if none of the previous cases are executed. So here we can print goodbye. Okay. Now, because the default label is the last label in this block, we don't need a break statement here because there is nothing after in this switch block. So the control will move out of the switch block. Okay. So we don't need the break statement here. Now compare these two implementations. So here's the implementation using a switch statement. And here's another implementation using an if statement. Now, this is where people have different opinions. Some people don't like switch statements. As you can see, this code is a little bit more verbose than this code. But on the contrary, it's kind of easier to the eyes. It's easier to read this code. So this is where different people have different preferences. There's really no right or wrong here. Use the approach that you prefer. Just remember, with switch statements, you can only compare variables with certain values. So here we cannot check to see if input is greater than 1 or less than 1 and so on. We only have an equality comparison. So basically we use a switch statement to compare a variable with a set of values. So in terms of functionality, they are not as flexible as if statements. With if statements, we can write complex logics, we can write complex Boolean expressions, we can use our logical operators to combine multiple conditions. We cannot do any of these things with switch statements. Now, as your exercise, I want you to create a basic calculator. So ask the user for 2 numbers and an operator, then print the result of applying the operator to those numbers. And if the user enters an invalid operator, then you should print a message like invalid operator. So spend a couple minutes on this, then come back see my solution. All right, we're going to start by printing a message like enter two numbers. Now we need to declare two variables, so first and second. Of course, we could declare them as double as well. It doesn't really matter. Next, we use cin to read these two values. Next, we need to read the operator. So note that I'm separating these statements from the next set of statements. So here we're going to read an operator, enter an operator. Now, the operator can be addition, subtraction, multiplication, or division. So for that, we need a char. But here's the thing. If we call this operator, look, we have a compilation error because operator is a reserved keyword in C++. And that's why it's indicated by pink here. So we need to call it something else like op, okay? So we use cin to read the operator. Now this is where we can use the switch statement to compare the value of this variable with a set of values. So we say switch op, we add braces. Now we have one case for the addition operator, which is a character, okay? Now, in this case, we want to print first plus second, and then we need to break out of the switch statement so the following lines are not executed, okay? Now, because this is repetitive, I'm only going to add two cases. So the other one is for subtraction. And here we're going to print first minus second. And once again, we need to break out. So I'm going to leave out the others for saving time. Instead, I'm going to add a default label. So if the user enters an invalid operator, then we print a message and say invalid operator. Okay? And once again, we don't need a break statement here because the default label is the last label in this block. Let's test our program real quick. So we're going to enter two numbers, 10 and 20, and plus as the operator. The result is 30. Beautiful. What if we use subtraction? We get minus 10. Perfect. And what if we use an invalid operator? So 10 and 20 with, let's say, an ampersand. We get invalid operator.